In this video we will look at the sine and cosine rules, just what they are and a brief example. Let's just remind ourselves the sine rule for some triangle that is a non-right angle triangle. We can use the rule for triangles that are non-right angle triangles, at least in Euclidean geometry. And we see that this triangle A, capital A, B, C, with side lengths small c, opposite angle C, small a, lowercase a, opposite uppercase angle A, and side length lowercase b, opposite angle B. And there is a relationship, and that's the sine rule, is essentially that side length A over the sine of angle A is equal to side length B over the sine of angle B is equal to the side length C over the sine of the angle C. All right. Similarly, for the same triangle, the cosine rule is triangle ABC. Right, let's pick this angle in here and label that theta. Then the lowercase letters represent the side lengths again, side length B, side length A, and this side here of length C. And the cosine rule tells us C squared, opposite the angle here, is equal to A squared plus B squared minus 2AB cos theta. We could have picked any of the other angles and given them a label, the same rule would apply. It's really just, if you take off the end bit, the negative part here, the negative term here, then you've just got Pythagoras' rule, which would apply for a right angle triangle. When you don't have a right angle triangle, this little bit here is added on. Okay, so let's use this in an example to see how this operates. Okay, so let's find theta for this particular triangle here. Call this side length C, give it 7 units, whatever they are. This side length here, B equals 4 units, and this side length here, A equals 5. And we'll nominate this as our angle theta. This is the angle we're trying to find for this particular problem. How do we use the cosine rule for that purpose? Okay, well, as we saw above, the cosine rule is C squared is equal to A squared plus B squared minus 2AB times the cosine of theta. Okay, let's just rearrange that, take the negative part over the other side, and also take C squared over here. We're left with 2AB cos theta, because remember it's the theta we're trying to find, the angle theta, is A squared plus B squared minus C squared. Divide through by 2AB, and we're left with cosine theta is this object here. All right, now we'll substitute in the values, and we have, let me just move it down a bit, we have here 25, 5 squared is 25, 4 squared is 16, minus 7 squared is 49, over 2 times 5 times 4. All right, tidy all that up, add sum the numerator, and we'll end up with negative 8 on top and 40 underneath. Okay, as a decimal, that's negative 0.2. Okay, just let's bear in mind though that the cosine is negative in the second quadrant. Remember, sine, cosine, and tangent are positive in the first quadrant. Cosine is negative in the second quadrant. And so in the second quadrant, the angle theta is found by the relation 108 from the symmetry properties by 180 degrees minus inverse cosine of 0.2. Okay, so in the first quadrant, cosine of theta is 0.2. Okay, but in the second quadrant, to find this when cosine is negative, we need to write 180 degrees minus inverse cosine of 0.2. When we solve for that, we get 101.5 degrees. That's our angle. Okay, so just bear in mind. So what we do is we find the relative first quadrant angle, and by setting cosine theta equal to plus 0.2. So we find out the value in the first quadrant, and then to find out its value in the second, we do 180, or pi, minus inverse cosine of 0.2. That's the first quadrant angle. All right, and that gives 101.5 degrees. Looking at the triangle, that's what we expect. We didn't expect an angle less than 90. We expected a bit more than that. Okay, that is that. That is the sine and cosine rules.